Alright, girl. Let's start working on some of these. Okay, so, oops, this is supposed to be a 10, not a 0. Okay, so where we left off in tutoring today in session A was you had taken your, I think it was a 4th degree polynomial, and you divided out the two real zeros, and this left you with this quadratic. Once you have that quadratic, okay, since it was an x, let me pull up your email real quick. Yeah, it was a 4th degree. Since it was a 4th degree polynomial, you know you should be looking for 4 solutions. Well, you already had 2 of your real ones, -2 and 3, so there's your 2 real ones. This quadratic is going to have your 2 imaginary, roots to it. So remember, quadratic formula, it's going to be -b, so +2, plus or minus the square root. Your b squared, so -2 squared, minus 4 times your a times your c, all over 2 times your a. In this case, it would be just 2. So if we simplify what was underneath the radical, just typing in that parenthesis -2 squared minus 4 times 1 times 10, we end up getting -36, all over still 2. Well, the square root of 36 is 6, and that negative being underneath there just means that it's going to come out to an imaginary. So the square root of -36 is a 6i, because the negative, again, makes the imaginary, and the square root of 36 is 6, so it's still divided by 2. Now from there, each one is divisible by 2, so it becomes 1 plus or minus 6i. So for number 1, your solutions to this one, I'll put them up here, should be -2, +3, and then 1 plus or minus 6i. Some students will write those out separately to show the 4 solutions. A lot of times, if they're the same, people just put plus or minus. Okay, so moving on to number 2. Okay, so number 2, the only thing that I'm thinking is possibly when I typed it in the calculator during A lunch today, that it didn't, maybe I hit a button wrong, I don't know. But I grabbed it once I got home and realized that it actually crosses my x-axis at -5. So I must have hit a button wrong earlier today, I guess, I don't know. So in this case, we do have an x-intercept of -5. So kind of like what you did earlier today, you're going to have to use synthetic division and divide out -5. That'll bring it down to a quadratic, and then you can use quadratic formula again. So my numbers are 1, -3, -15, and 125. Use our synthetic division. -5 times 1 is a -5. We add down, we get -8. -5 times -8 is +40. We add down, we get 25. And -5 times 25 is -125. We get our remainder of 0, which is what you want. Okay, if it's a true real root, you're going to have a remainder of 0. So if you need anything from this, go ahead and get it or pause the video. I'm going to erase the screen so that I can go through and add another part to it. Okay, so we started with an x to the 3rd, so now we're going to be left with an x squared. I want to keep these bottom numbers so I know what I'm writing up here. So I know it's going to be an x squared, so it's going to be 1x squared, or x squared, minus 8x plus 25. Looks like that's going to be my quadratic. So we just go through and do quadratic formula again. So -b, which will take that to a +8, plus or minus the square root. Our b squared minus 4 times my a times my c, all over 2 times my a. Well, again, all we have to really do is simplify what's underneath the square root. In this case, it comes out to, again, -36. So just like the last time, plus or minus 2. Square root of 36 is 6i. And again, both of these are divisible by 2. So it becomes 4 plus or minus 3i. So there's my 2 imaginary roots, and then we already had our real root. Our real root was -5. So x equals -5 as well. Okay. And it was started out as a 3rd degree polynomial. We had to find 3 roots, one in this case 1 real and 2 imaginary. Okay, so now we're going to move on to number 3. Let's switch screens. Okay. Now, number 3, you can go through and graph it if you want to, and you would end up crossing your x-axis at +7 and -7, and then divide each of those out and get your quadratic and all that kind of stuff. Same kind of thing, about the same length as number 1. However, this one in its form, the way that it is, actually is going to factor pretty darn nicely. It's an x to the 4th, x squared. This one, to me, is actually faster if you factor. In order to get an x to the 4th, they're both x squareds. And you basically do the same thing that we've done with factoring before. Figure out two numbers that are going to multiply to this, but add to that. So in this case, two numbers that will multiply to -49, but add to -48 would be -49 and +1. Well, this first one's a perfect square, so that one will factor nicely to x plus 7 and x minus 7, which again are going to give you your two real roots, so plus or minus 7. And so I was saying, if you had graphed this originally, it would have crossed your x-axis at +7 and -7. So there's those two real roots. And you could have divided using synthetic division both of those out of this original, and you still would have been left with this same quadratic right here. Well, this quadratic, in order to solve or find my solution, we just set it equal to 0, and we continue to solve. Well, now to get rid of the square, you square root both sides. So we get x equals plus or minus the square root of -1. Again, the negative makes it imaginary, and the square root of 1 is 1. So this becomes plus or minus 1i, or just plus or minus I. It's however you wanted to put it. This one, again, would have been, to me, probably a little bit longer if you would have divided out the +7 and the -7 using synthetic division like number 1. You still would have ended up with the same quadratic. I always tell my kids to go through and graph first. Graph first, get your real roots. If you divide them out, divide them out. If it factors nicely, factor. Or, if you don't like factoring, you don't have to factor. Alright, so number 4. Alright. So, number 4, I went through and graphed this one first. And I find that it doesn't cross the x-axis at a nice point. But when I looked at it, the point was -0.2. -0.2 is the same thing as -1/5. So that is one of my real solutions, and we can use synthetic division, even as a fraction. Oops, sorry, 1/5, not 1/2. Fix that. So I'm left with -5, +9, -18, and -4. And this one, even with synthetic division, is still going to come out to nice numbers. -1/5 times -5 is a +1. Add down, we get 10. -1/5 times 10 gives us -2. Add down, we get -20. And -1/5 times -20 gives us a +4. Again, there's our remainder of 0. So that leaves us now with our quadratic. So -5 x squared plus 10x minus 20. And we can go through and use quadratic formula for that. And find our imaginary solutions. Okay, so with this one, we'll go through, I'm going to erase the top off, I guess. Okay, alright, takes a second to get it all off there. Okay, so if we go through and do our quadratic formula to it, it's going to be -b, so -10, plus or minus the square root, our b squared, minus 4 times my a, which was -5, times my c, which is -20, all over 2 times my a, and this one come out to -10, because 2 times -5 is -10. Again, you always want to figure out what's underneath your radical first. And if I just solve the number underneath the radical, I get -300. Now, while -300 is not a perfect square, it can break down basically to 100 times 3. Well, and a negative, that just makes it imaginary. So we get negative 10 plus or minus 1 over negative 10. So the square root of negative 300, we know it's going to be imaginary. And the square root of 100 is 10, so that's going to become 10i with the square root of 3 left underneath. Each one is divisible by 10, so negative 10 divided by negative 10 is positive 1, plus or minus. Now I know it's going to seem a little bit weird here because 10 divided by negative 10 is negative 1, but because it's a plus and minus in front of it, you actually don't have to put that. So it just becomes I square root of 3. So there is our two imaginary roots, and our one imaginary root was 1/5, I think it was. Negative 1/5, I'm sorry. So there is our three roots for that one. Alright, I'll very shortly get you started on number 5, just in case you needed it. So, on number 5, because you said you had to go through 8, it's going to give you the roots. You have to figure out the polynomial to it. So just remember, when you put it back into factored form, you change your signs. So that'd be x plus 4, x minus 1, x minus 7, and you multiply this thing out. So when I multiply this one, I get x squared. I'm going to do these two together. So negative 1x and 4x would give me a positive 3x. And 4 times negative 1 is negative 4. And now we multiply that bad boy out to each one. So we get x squared, or sorry, x to the third. Negative 7x squared, positive 3x squared, minus 21x, minus 4x, plus 28. And if you combine your like terms, get x to the third, minus 4x squared, minus 25x, plus 28. And there's the polynomial that will give us those roots. Okay, so the rest of your other ones are the same way. Hope that helps, dear.